axis of curvature. What is the principal axis? Line joining the pole to the center of curvature is called like a principal axis, and this is called like a aperture. Okay, let's see the. Now we'll go for the like a tracing, like a how to, if a light is incident, if a ray of light is incident, what will happen to the reflection concept here? We have to apply here the idea of the reflection. There's a normal. Let's come for this one. There's a concave mirror. The inner surface is available for reflection. A ray incident parallel to the principal axis. Look at this ray. A ray incident parallel to the principal axis. After reflection, will pass through a point on a principal axis called as focus. I'll call this as this particular point. We'll call it a focus here. So what is F? This F is called as a focus. At one particular point, the ray will intersect the principal axis here. That particular point, I'll call it a focus. The distance measured from the pole to focus is called as a focal length. That is what is small f. Later on, we'll define that one. That is called like a focal length here. So this particular point is called as a focus. If a ray is incident parallel to principal axis, you see this one. There's a principal axis, this one. These two are parallel. After reflection, the reflected ray will intersect the principal axis at a point called as a focus. Now, if a ray is incident at pole, it will be reflected symmetrically because the angle of incidence equal to angle of reflection. See here also, don't think that everywhere the laws of reflection will hold good. That there's no problem with that one. I'll stick on to that one. If a ray incident parallel to principal axis, after reflection, it will intersect the axis at a point called as a focus. No, if a ray is incident symmetrically, sorry, if a ray is incident at a pole, it will be reflected symmetrical because this will become normal. So what is this? This principal axis will become normal now. Now angle of incidence should be equal to angle of reflection, so that it will be reflected symmetrically. Now similarly, if a ray passes through a focus, after reflection should become parallel or nothing but the principle of reversibility of light concept. If there's an incident ray, this will be reflected ray. If this is the incident ray, then this will be reflected ray. The similar idea. Now what is this yellow color? This will become normal, no? It has to be normal. Now, similarly, if a ray passes through a center of curvature, then what is the angle of incidence? Because this will become normal. Because this ray, what is the angle of incidence? What is the angle of incidence? 0. Angle of reflection should also be 0. So it will retrace path. So what is the conclusion we can make it? A ray passing through center of curvature after reflection retraces path. Don't say it goes undeviated. Angle of incidence equal to angle of reflection, so it will retrace a path here. Fine. So these are the primary rays what happen, which I'll be using to trace out the image. So once again, I'll revise it. If ray is incident parallel to principal axis, after reflection, it will intersect the principal axis at a point called as a focus. Then, if a ray is incident at a pole, will be reflected symmetrically. Angle of incidence equal to angle of reflection. Then, if a ray passes through a focus, if incident ray passes through a focus, after reflection, it will become parallel to principal axis. This is a reflected ray. This is incident ray. Then, if a ray passes through center of curvature, it will retrace path. It will retrace path. Because the angle of incidence equal to angle of reflection. Okay, now after this. Definitely I'm interested how this distances are related. What is P, geometrical center? What is C, center of curvature? I'll focus. So the distance PF and PC, how they are related. Let me assume a paraxial ray. Okay, time being. Okay, what is the paraxial ray? rays whose angle of incidence are very small and M will be very close to the P is called like a paraxial ray. So what is the basic idea of paraxial ray? A ray. Okay, I'll write it here only. Theta very small and M lies close to P. Then if for this condition, the incident ray will become a paraxial ray. Paraxial ray doesn't mean that it is parallel to principal axis. I think this will be wrong idea. Here for convenient purpose, I just took a ray which is parallel to principal axis. Paraxial ray doesn't mean that it's a parallel to principal axis. Means here, is it a paraxial ray? Yes, it is. Is it parallel to principal axis? No. Is it a paraxial ray? Yes, it is. So is it parallel to principal axis? No. Fine. So paraxial doesn't mean that it should be parallel to principal axis. If angle of incidence equal to if angle of incidence is very small and if M lies very close to the P, then this will become a paraxial ray. Okay, let's apply the laws of reflection. So this particular thing is called as a normal, no? Then angle of incidence should be equal to angle of reflection. Then the ray is parallel to principal axis after reflection will pass through the focus. Let this be different. Since angle of incidence equal to angle of reflection. Okay, fine. We know this MC will become radius of curvature. This is equal to R. Even PC is equal to R. The distance PC is equal to R. Then look at this triangle. So will this be an isosceles triangle? Yes, it is. On the reason, what is the reason for that? There's a normal, this angle of incidence should be equal to angle of reflection. Even this angle should be theta because this ray and this principal axis, they are parallel. So therefore, this should be this angle should be the theta. Okay, agree this. Then afterwards, then look at this angle. Angle FMC should be equal to angle MCF. Any reason for that? Again, look at this one. This ray is parallel. After reflection, passes through focus. So what can be alpha? Alpha should be 2 theta from the geometry. Alpha should be 2 theta. Alpha should be 2 theta. If alpha is 2 theta, then this angle is theta. Then this angle is theta. Then this will become like an isosceles triangle. So because of that, now what we can write is like from the triangle, B MCF should be equal to angle FMC. It's an isosceles triangle. Then the distance FC should be equal to MF. I'll write this data here. This will be much useful for you. Take it here now. There's one thing. Oh, no. F will be very close to the M will be something. M will be very close to the P. And from the isosceles triangle, so therefore what we can write is like a MF should be equal to PF because the M will be very close to the P. So MF should become equal to PF. Any reason for that? Because of paraxial, this condition is very important. Because of that paraxial condition is what I'm able to write that one. Let me shade that. And the incident ray is paraxial. So therefore M will be very close to the P. So the distance what you measure MF should become equal to PF. There's the one condition you put it. Now let me go for this triangle. So isosceles triangle. Then angle FMC should be equal to MCF. So therefore what we can write FC is equal to MF. FC is equal to FM or FC is equal to FM. Write it here. Okay, let's come for that one. As MF equal to PF, so what we can write here is this one. So PF is in fact is equal to MF, so like here MF is equal to PF because of paraxial ray. From this isosceles triangle, MF is equal to FC. Okay, let me write. What is PC is equal to? PC is equal to PF plus FC. Now, what is PF? Okay, that is the focal length. What is PC? That is equal to R. How these two are related is what we are trying to get a relationship here. And we know MF is equal to PF. If MF equal to PF from here, and MF is equal to FC. So therefore, shall we write PF equal to PF? Okay, so something happened here. I'll write the steps so that will be easy for you. No. So this FC is what needed, no? What to write FC? FC, I can write it as MF or FM. And FM, you can write it as PF. So I'll write all these steps. It'll be very easy for you. This PF, FC, I can write it as MF. Then further, MF, we can write it as PF. This will become 2PF. What is PF? We'll write PF is in fact equal to, already I written, no? Why this one? Now, what is PF is equal to small f? What is PC? PC should become equal to R. I'll write one more step. Okay, some of you are getting confusion. PC is equal to 2 times of PF. So this is R, this is 2F. So finally, what is F? F is equal to R by 2. So how the focal length and radius of curvature for a paraxial ray are related? This one. So this is applicable for purely for paraxial ray only. Once again, I'll just summarize it. There's a ray. If M is very close to P, then this will become a paraxial ray. Theta should be very small. M should be very close to the P. This will become paraxial ray. Then angle of incidence equal to angle of reflection. This is a normal. Then the reflected ray will intersect the principal axis at a point called as a focus. Then this is called like a focal length. The distance is called like a radius of curvature. How focal length and radius of curvature are related. Okay, let's see one thing. Due to paraxial rays, MF should become equal to PF. This is the condition. Next again, let's look at the geometry. That one, angle FMC should be equal to angle FCM. Okay, fine. Then, so from this, because of isosceles triangle, so MF should be equal to FC, or FC is equal to FM. Anything in this one? Okay, no. What is the distance? PC is equal to PF plus FC. PF, let me keep as it is. Then FC, I can write it as MF. No. What is MF? And we know MF